Good afternoon, everyone. This is Sadia Zafar from HRAI. I would like to welcome you to today's session on indoor air quality and UV technology. The session is brought to you by UL. In this webinar, you will learn about air cleaning technologies for efficacy and how they are verified to meet existing safety standards. A little bit of housekeeping. You will notice on the control panel of your screen the Q&A feature. Please use the Q&A feature to ask your questions at any time during the webinar. They will be addressed at the end of the session. Also note, this webinar is being recorded and the recording will be shared with you following the session. We will begin the presentation. First, I would like to welcome Vasilios Soupos.
Thank you, Sadia. Can you see me and hear me okay?
Yes, I can.
Thank you. Welcome, everyone. My name is Vasilios Soupos. I'm the Business Development Manager for Appliances, HVAC, and Components for the American region. And today I'm excited to bring you two very special speakers. I'm going to introduce them in a minute. But first, I wanted to give you a brief introduction as to who UL is, what we do, in case you haven't heard of us. So I'll start with that. So UL, we are the global safety science leaders, and we provide the expertise, insights, and services necessary to solve critical business challenges. We help our customers achieve their safety, security, and sustainability goals, meet quality and performance expectations, manage risk, and achieve regulatory compliance. In the course of our work, we meet extraordinary people whose companies are having an extraordinary impact on the world and creating the future. UL's rigorous scientific process, experience, and solutions empower our customers to innovate fearlessly and drive positive change. We never stop working for a safer world, and our offerings continue to evolve with advancements in science and technology. We provide testing, inspection, and certification, training, advisory and risk management services, decision-making tools, and intelligence to help our customers, based in more than 100 countries to meet important business objectives. All of our offerings have one connecting thread, which is trust. Confidence drives commerce, and trust and innovation is essential to market access, business success, and better living. UL empowers trust. So that is what we do in a nutshell. And as I mentioned, I wanted to introduce two very special speakers, Brian Rogers and Scott Laughlin. Brian, who will be going first today with his presentation, is one of our principal engineers for the HVAC product categories. He has more than 31 years of experience in standards and holds numerous leadership roles with multiple standards developing organizations, or SDOs, including a voting member of ASHRAE 15, 15.2, 37, Low GWP, and corresponding member of ASHRAE Technical Committee 2.9 and TC 8.11. He convenes IAC 61C MT1, IAC 60335-2-34 for motor compressors. He's member of the IAC SC 61C, member of IAC SC 61D, Working Group 21, numerous committees, member of the US TAG for IAC SC 61D, and TAG advisor and holder for IAC SC 61C. Lastly, Brian is a William Henry Merrill Society member, distinguished technical member of UL, and has extensive experience in the development of US regional and international safety standards, and was recognized with the 1906 award for his work on the IEC SC 61C MT1 for motor compressors. Thank you for all your work, Brian. Secondly, I wanted to introduce Scott Laughlin. Scott Laughlin is a product manager for the UL Green Guard certification program at UL in Marietta, Georgia. He has a Bachelor of Science in Environmental Economics and Management from the University of Georgia and a Master of Public Health in Environmental Health from Emory University. He works with manufacturers to understand chemical exposures, specifically emission characteristics of furniture, building materials, electronic and medical devices in commercial, educational, residential, and healthcare settings. He's also the co-author of UL 2905, Outline Investigation for Validation of Indoor Air Quality Sensor Performance in Non-Industrial Buildings. Prior to his current work with the UL Green Guard program, Scott was a forensics buildings consultant with a focus on moisture damage and indoor air quality, working on a variety of restoration and remediation projects. So with that brief introduction, I wanted to pass the presentation over to Brian to start with the content for today's webinar. Thank you.
Thanks, Vasilios. Again, Brian Rogers here. I'm the HVAC principal engineer, and today we're going to talk about the requirements for UV lamp systems mounted in the ductwork of your residential buildings, your commercial buildings, industrial buildings. It really doesn't matter the installation, but making sure that those lamps are installed safely and will not leak out any irradiance that could affect the occupant's skin or eyes. So next slide. So this is just kind of a blurb out of our lighting site, where our lighting group has many different categories of lights, but in there it refers the manufacturer, the person looking for information on duct mounted UV lamp systems. And again, the standards we use in the US are UL 1995, and the lamp system itself has to be certified to UL 1598. Whereas in Canada, we're looking at the UL or the CSA 22.2 number 236, which is a binational standard with the UL 1995. And the luminary standards are the CSA 22.2 number 12 and number 250. So those would be the standards we look at in the UL category code. If you're a UL customer, you know what those are, but everything will be gathered under that ABQ category within UL. So next slide. So again, today we're really just talking about, and we have really three different classifications of these lamps, where they could be installed by the manufacturer of the HVAC equipment. They could be designed and ready for hookup to be field installed, but it's still the HVAC manufacturer's lighting system. And these specific requirements are for, if there's already obviously an air conditioning system within the structure and a duct system, and the reasons being that the COVID and so forth, that building owners want to install these UVC disinfectant lamps that will help kill that bacteria that grows on the evaporator coils, the condenser coils, because they're a wet location, and bacteria and those things try to adhere to it. So these requirements are really looking at the field installed lamp systems. When you have an existing piece of equipment, the HVAC and ductwork are already in the structure, the building owner says, hey, I want to put in a UVC lamp system that's going to help add to the safety of the occupants of that building. And again, we're still looking at the lamp system itself has to be certified or listed to 1598 or 153 or the CSA 250, and I believe it's 12. So that's what we're looking at. So next slide. So one of the big safety things we have here is, as you know, these UVC systems, they can cause, they have some very intense light, because they're killing bacteria at this 254 wavelength, where, and that's what we want them to do. But if somewhere to enter that enclosure, because we also have to have filter systems to keep the dust and all that type of things off the coils so they don't get clogged. We want those access ports where the UV lamps could be shining on that coil to kill the bacteria, which really is going to leak through and be, it could affect the filters and that type of thing. So we want to have an interlocking mechanism. So in that, the building maintenance guy goes in there to change the filters, he's going to open up that door, and these lamps are going to automatically go off, because we don't want him to have his skin exposed, his eyes exposed to that lamp because of the intensity. And this is required anything over 1.7 microwatts of irradiance. So it's a pretty high level, actually, and through the testing and so forth, they saw that a maintenance guy could actually be exposed to that level for an 8-hour workday. So if he's going into your building to change out the filters, as long as that is less than 1.8 microwatts, that it's your filter location, he can safely go in there and not damage his eyes or get burns on his skin. So that's what we're saying. You have to have an interlock on anything that, the standard says SA 17.3, but that value is 1.7 microrods. And we would measure those values during the testing. So next slide. So the provisions that you're going to look at, you're going to have to do is you got to either have provisions for a conduit connection. It's got to be a cord, or if you didn't want conduit, you got to have a flexible cord with strain relief, a pressure or screw terminal block, provisions to connection of that cable, and the power cords really need to meet the requirements of the Canadian Electric Code. So we say it, we call out some clauses here in 1995, but it's ultimately what's in the Canadian Electric Code that we're looking for. And again, that cord, if it's inside the unit, not in conduit, that has to be UV resistant material as well in that, so we don't degrade the insulation on the cord. Next slide. So materials in the duct, when you look at the building codes, they require any non-metallic material that's in that duct space that's non-metallic. You meet in the US is NFPA 90A, and in there we have requirements for smoke and flame ratings, and in that is in the code it requires you testing to UL 723 or UL 2043, and that gives you a smoke and flame rating. Where if one of the biggest problems or issues you would have in a building is spreading smoke throughout a building and causing panic throughout the building. So we do not want to have a component that is non-metallic in the duct that would develop smoke that would be transferred throughout the building. So we would do this testing to UL 723, and that gives you what they call a 2550 rating, so a smoke developed type rating. So we would require anything that's non-metallic up and above that UL 1598 standard, that those materials that are non-metallic would have to meet those requirements, so they don't smoke and create a panic hazard within that building structure. So next slide. So another test that goes above what is required in 1598 is we have to have an elevated temperature test, because you think of a plenum for an air conditioning system, and obviously in Canada and the northern US, all those would have gas or electric heat in that same space. In the plenums of that space, we can see temperatures up to 200 degrees F. So if that lamp were to be on that coil, it's going to be exposed to temperatures up to 200 degrees F. So we would either the manufacturer of the lamp would have to have an elevated temperature test to make sure all the components would not overheat at those temperatures, or we would do that in the end product to make sure that those components within that lamp system would not exceed their temperature limits based on that elevated temperature of 200 degrees F. Next slide. So again, resistance to UV radiation, you think about a coil, and underneath that coil is a drain pan, because obviously it's wet, and as it frosts and freezes and so forth, it's kind of an automatic defrosting type system in an air conditioner, where that condensate water is going to flow, and it's got to flow into a condensate pan. Most people in the last 15, 20 years have gone away from those metallic drain pans to plastic drain pans that are non-metallic drain pans. Those have to meet the requirements that they aren't subjected to, they're subjected to that irradiance level, that they would not be affected and degraded. And obviously you don't want water flowing in your ducts and throughout the HVAC equipment. So we're going to make sure that those non-metallic parts there would also not be degraded, including any of your wiring that could be associated with it, connected to your fan blades. You could have fan blades in a plastic fan blade as opposed to a metallic fan blade. We do not want that UVC lamp to degrade that fan blade, which could cause it to dry out, crack, and you could have the blades break off and actually damage the coil, or create a leak in the refrigeration system. So it's very important that any non-metallic component within that HVAC system is not affected by that UVC system. So we're going to measure the irradiance and do the testing accordingly to make sure that those parts, but if you go in there and shield them, it's doing the same thing. So if we would either test to say, yeah, your irradiance level is so low, we don't have to worry about that non-metallic part, or you shield them. And what have we seen a lot of people do is take on a drain pan, is just either replace that drain pan with a metallic one, or they use that aluminum tape and tape over where it could be exposed to that, and it really provides the same bit of security. So next slide. So this is kind of the nuts and bolts of it. We don't want, especially you think of a residential type system where you have one of these systems, you want to put it in your home. We don't want anything leaking out of that system into the occupied space of more than 0.1 microwatts. Because you think if you're, you have a split house and that HVAC system in your home is on a level where you have a child, what does a child do when they see a light? They get as close to it and they stare at it. Where we want to protect anybody that especially children that are kind of distracted by lights and really just kind of sit there and stare at them. So we don't allow anything out the system more than 0.1 microwatts. Again, for the service guy that's going to go in there and be exposed, he's trained. He knows that UV lamp system in there it can be dangerous. It's going to affect your eyes and your skin. We're allowing up to 1.7 microwatts, and then you have to have obviously there's marking that would tell them that there's disconnect the power. But if you don't have that, if you exceed that, then you have to have interlock on anywhere you're going into that air conditioning system to change the filters, oil motors, any of those type of things. So it's those are our two safety levels, and they're really governed by the ACGIH, which is the American Conference of Governmental Industrial Hygienists, and they set those values and did all the testing to say that these are the levels people can be exposed to for an 8-hour period and not have any damage done to them. So next slide. So as we said all that, there's a transition from the UL 1995 CSA 236 to the UL CSA 60335-2-40. So January 1st of 2024, the 1995 236 is going to be transitioned all into the 2-40. So there are very similar requirements. And actually, we put those into the IEC standard as well. And they're giving, as we've learned more about the different lamp systems and the irradiance levels, the values are a little bit higher. I think it goes up to 0.2 microwatts for the exposure of just coming out of the system itself. Any leak in the duct or any leak in the HVAC system, you're allowed to go to 0.2 microwatts. So, but that's available in the 60335-2-40 standard, which covers both the every place in North America. So it's it's a binational standard with CSA. So that's all I had on this. So we'll transition into Scott, and we'll answer any questions you have after Scott's finished with his presentation.
Great. Well, thank you, Brian. That was very educational for me. I hope for the audience as well. So I'm going to be talking about CARB, which is the California Air Resources Board. They have an air cleaner ozone certification program, and we have a validation which is called UL 2998, which is basically saying that an air cleaner is producing an extremely low level of ozone. So if we could go to the next slide, I'm going to start looking by looking at what is ozone. So, the EPA in the United States defines it as a highly reactive gas that has 3 oxygen atoms, so O3. It's both natural and man-made, which is a little odd to think of. But so, the first thing that I often think about if I hear ozone is the ozone layer. When I was much younger, and it was a huge problem with people spraying CFCs around and creating a hole over Antarctica. It's great to have ozone in the stratosphere. It's naturally occurring. It absorbs UV light. It reduces that UV exposure for people, as Brian said. That's very important. But ground level ozone, or tropospheric ozone, as it's often called, is typically man-made. So the reason that CARB, California Air Resources Board, originally got involved with the ozone work that they do is because of smog regulations in the state of California. So they're unique in that aspect. There aren't any other states that have an entity that does rulemaking the way that CARB does in California. But they have the carve out because of smog issues that they've been dealing with for quite some time now. So, why is ozone in the troposphere not as great? Well, it can be created a variety of ways. It can either be created sort of in the classic smog sense with, car exhaust mixing with sunlight outdoors, but it can also be generated intentionally in some cases by air cleaners or other types of devices, even UV lights at certain wavelengths. And when it's inhaled, it can be a very powerful irritant. Going back to that highly reactive part. So, you can end up with throat irritation, pain, discomfort in the chest, tightness, wheezing, shortness of breath, all sorts of stuff, asthma-like symptoms that can come, especially in people who are susceptible populations, children, immunocompromised individuals, things like that. And so, the chart that I have at the bottom right, you see that's the rating system that we have in the United States for an air quality index. It's typically related to ozone concentration over an 8-hour average, outdoors. So you'll see that ranges all the way up to 400 parts per million, which is pretty high, and then that can get to the very unhealthy range. Health Canada does have a recommendation for residential exposure over an 8-hour time period of 40 micrograms per cubic meter, or 20 ppb of ozone. But we're going to get into a little bit more about the where that how that interacts with the air cleaner regulations that we have. So next slide, please. So a little bit of background on where we've come from to get to the ozone testing requirements that we've had. Like UL 1995 that Brian was describing, UL traditionally has quite a bit of work in product safety standards. So you'll see these three listed here: 867, 507, and 1598. UL 867 is the one that we interact the most with. It has a carve out specifically for if you are testing an electrostatic air cleaner for safety. So things like, interlocking of filters and making sure that it has electrical and fire safety componentry and testing that's done. There's also a test that is required for making sure that it has a low level of ozone. And that level for UL 867 would be less than 50 parts per billion. You'll also see it as 0.050 parts per million, same thing, just move the zero over. And so that's been required by CARB for portable electronic air cleaners since about 2007. In 2020, they expanded their regulation to cover in-duct cleaning devices. So rather than just the ones that are, sitting out on wheels or tabletop type models, it also covers those could be used in-duct. And so manufacturers have until October 1st of 2022 for those types of devices to come into compliance with that, to have testing that's showing that their product is less than 50 parts per billion of ozone. And if not, they're not allowed to sell their product into the state of California, which makes it incredibly inconvenient as a manufacturer to sell your product really anywhere. So, it's by default sort of a nationwide requirement. And so the UL 2998 ozone validation is we take that UL 867 testing that we do in the lab that I work in Atlanta, And we're validating that the product would have less than 5 parts per billion of ozone, which is something that was recently added into the requirements of ASHRAE 62.1 for induct electronic air cleaners. So there's, you see in the middle there, there's also an alternative duct test. So it's called CSA 22.2. CARB accepts both for in-duct testing, but UL 867 is considered more of a worst case scenario, because essentially we are taking that product, if it's, let's call it maybe it's an ionizer that goes inside of a duct. We're running it inside of it's a dynamic chamber, but it's not having the same amount of air that's being passed over it the way that it would in an active duct environment. So in a way, it's more of a worst case for that product. So let's go to the next slide. So CARB defines indoor air cleaning devices as, I'll just read this quickly. So it's an energy using product that a stated function is to reduce concentration of airborne pollutants from the air, including but not limited to allergens, microbes, dust particles, smoke, fumes, gas vapors, odors, chemicals. And then where it's important is it includes portable devices, standalone devices that are designed to be attached to a wall, or electronic indoor air cleaners. And then that's a version of what the label that they ask manufacturers to put on if they are required if they do meet those criteria. And so CARB does list, if you go to the next slide, please, CARB does list currently certified devices. I have a URL there on the slide. And they divide devices into 2 categories. One is mechanical, which only use the physical filters. And the other, and the one that we're really thinking about here, is electronic air cleaners. So they, again, have to produce that less than 50 ppb of ozone, and includes all these different kinds of technologies that you guys have likely heard of, and also some with UV light components. So, in this most recent revision to the CARB standard, they did change the definition of UV light to sort of narrow it a bit, so that it's basically, they're saying UV light is from a light source that only emits wavelengths greater than 240 nanometers and produces no measurable ozone. So on the next slide, this is just an overview of how you would go about getting an air cleaner certified. So you first have to get an application number from CARB. So you reach out to CARB directly so that you can be in their system and eventually be listed on their website, hopefully. Have the product needs to be tested by a nationally recognized testing laboratory, NRTL. That's where we come in. There are other providers of this service as well. But and then if the device is subject to that ozone test requirement, it has to go through that that testing by a CARB-approved laboratory, and then you would submit all of the applications, supporting documents to CARB, and then they would be able to give you 30 days to finish that initial review, and then load that onto their website. So we can go to the next slide. So as I alluded to, UL 2998 is what we call an environmental claim validation. So you'll say it says validated on the badge there, and so we're measuring that. It can be applied to complete devices or to components if they're below that 0.05 or 0.005 ppm or 5 parts per billion level for ozone. That it's, as I mentioned, it's referenced in that ASHRAE 62.1 document. And then as part of that 2998 certification process, we're going through and completing that application for CARB as well. And so it's just sort of an extra, sort of an A+ rather than an A, saying that, your product, yes, is legal to sell in the United States, but on top of that is going to have that essentially 0 level of ozone that's coming off of it. And so the way that our validation process works is that, you do an initial validation for a product, and then we would come back in, do surveillance type audits, and then sort of a recertification every 3 years or so. So let's go to the next slide. So this sort of drills down on that just a little bit more. So, when we're going through UL 2998, the manufacturer is typically submitting all of that relevant information to UL. This is sort of after you start that process with CARB, sending 2 identical devices to us. The engineers that are doing the safety certifications, the UL 867, basically everything except for the ozone portion, are looking at all the different models, trying to figure out, okay, how can we group these together? Are there different operating modes that we can run these in where it would create more or less ozone, or none or some ozone? Checking voltages to see if, what the critical components are. Essentially just trying to figure out how many tests that would be required in order to cover the widest amount of products possible. And then you would do the UL 867 testing, and you would be able to sort of tack on that UL 2998 validation should the manufacturer request that as well. So that's all I have for the ozone and the validation and the safety process. So the next thing I'm going to go through is about indoor air quality sensors and what we call UL 2905. Let's go to the first slide there. So if you've been paying attention to the news, manufacturing, communications, really anything, it seems like there are more and more, you would call them low cost or sort of consumer grade, enterprise grade indoor air quality monitors that have come out onto the market in the last 5 years or so. They create, have a variety of different types of sensors in them. And, there is one thing that we noticed from the beginning is that while they present data in these really beautiful ways, the accuracy of some of those sensors, while they can give you a number or a color or a check mark or a smiley face, trying to compare that back to a reference value and whether or not they're reliable is something that needed to be looked at a bit more. So let's go to the next page. So the thing that we've had indoor air quality sensing technology for a long time, mostly in the industrial hygiene space. So you have a factory, industrial space. You bring in an industrial hygienist or a consultant of some kind to take a variety of different kinds of readings, maybe take some tape slide samples and try to figure out what could be going on, typically in response to a problem. Where we are going is, putting these types of sensors, on a much more scaled down approach, but having many of them the way that you would have smoke detectors or thermostats in inside of a building. And, often they're paired with data dashboards. They are integrated right into the building management system. But, getting and displaying the data is not necessarily the hard part. It is, being able to rely on that. So we go to the next slide. This is the inside of one of these sensors. This is a SenseWare sensor that we were able to do some initial testing on last year. And just to give you a size comparison, right in the middle, I've circled, that's sort of a micro USB, phone charger or battery charger. So you can see how small all of these different nodes are. So you're, within this one sensing device, you've got, it's measuring TVOC with that, pin-sized sensor. You have carbon monoxide, CO2, HCHO is formaldehyde. You have a temp and humidity monitor. And then the largest of those is the particulate matter, 2.5 nanometers and smaller, PM 2.5. And so you can, typically build these, depending on what your application is, what you're trying to monitor. They do. It seems like they have advanced at the speed of any other computing type technology, where every few months or so, a model is almost obsolete and is being replaced. So it's interesting to sort of follow along with what this market is doing. So if you go to the next slide, really in our testing, we found that low cost sensors are really a valuable tool. It's good that they are somewhat useful because they are flooding the market, whether or not they are useful. So it's good that you can extract value from them. An issue that we did see in our testing is that the gas-based sensors, so things that are looking for TVOC or specific chemicals, formaldehyde, that kind of thing, they can be confused by sort of other confounding variables, whether that's humidity, or whether the product was placed in the breathing zone, or they could even be confused by other sources of chemicals. So if someone is has a personal care product on, a cologne, and they're walking by the sensor, you could have spikes. And so we were able to show that that they are pretty far off from being exactly accurate on like that gas phase type work. They're much more accurate in the the older technologies, which I would say are the temp and humidity sensors, and to some degree the particulate matter sensors as well. The value that they really bring is being able to show trending data. So if you have 10 or 15 of these deployed throughout a building, understanding, okay, on the second floor on Tuesday, we started having an issue where the particulate matter was much higher. You can really pin that down to a 30-second sample location, and then be able to see where that was, and maybe that's a filter that fell out of the ductwork, or maybe that's some other source of PM that's coming in that needs to be sort of fixed up a bit. And so really the picture is really to illustrate that using it for the right tool for the right job is really what you want to do. I don't see us using these in a lab setting anytime soon, but it's better to have some numbers, as long as you can sort of you can take into the caveat that they are you're looking at the trends rather than the absolute values that are coming off of them. So let's go to the next slide. So much like the other validation 2998, we have what's called a UL 2905 validation. And so that's based on an outline of investigation, which is sort of a brand new standard. It still has, it was just developed in the last 2 years. And so it has some work to do before it becomes a full-on standard. We have to test quite a bit more, get some other things through it. But in the meantime, it has all of the components that a standard would have. It does have, badges and, a review process. It follows that sort of 3-year timeline that we had discussed for 2998. It has 10 different analytes that we can determine to have the greatest impact on indoor air quality. And so you would have a grade based on which of those 10 are present in a specific sensor device. And this is this is for the manufacturers. This isn't something that we would do on site in a building once they've been installed. And so we test 5 identical devices. They would send them to one of our labs. We challenge them in a variety of ways. We're putting smoke and particulate into a chamber. We have reference instruments that are right alongside them. We're adding chemical sources as needed, lowering and increasing humidity and temperature, that kind of thing. And we're looking to have if you go to the next slide at the table there, the way that it's set up is to give ratings by each analyte. So an analyte would be, something like temperature, humidity, or TVOC. And you have three different levels, three different challenge levels that we would be able to challenge a product in. And so the idea is that you want to have RPD, stands for relative percent difference. So you want to have, to get the highest rating for each of those, you would need to have a less than 20% percent difference between the low, medium, and high as compared to the measurements that are coming off of those reference instruments. And so, we're still seeing, we've put a few sensors through this process. There's plenty of room for improvement, but we think that there is there's a lot of improvement coming on in the amount of accuracy we're seeing from some of these lower cost sensors I would not have imagined possible even 4 or 5 years ago. There are other groups that are doing work. Reset is a standard that you may be familiar with. They have a building standard as well that's built around indoor air quality sensors. It has similar, a similar backdrop to measuring performance. There are other types of standards that are being developed by ASTM, ISO. There's lots of work being done in this realm. So I would encourage everyone to stay tuned. The last slide, if you go there, is for Spot. So that is UL Spot is our online product database. So whereas if you have a product that's safety certified, maybe to UL 1995, there are separate databases where that would be listed, where an authority or a customer may want to go and verify that product is in fact UL certified. It doesn't have a fake sticker on the back of it. Spot is where we keep our environmental claim validations, our other types of environmental certifications. And so it's built around where the demand drivers are in these industries. So architects and designers, engineers, building managers often use this to find relevant and credible product data that we have on them. It's free to access, free to download. Product certificates should they be needed. It also comes into play when you have professional purchasers or government agencies that are trying to get certification documentation that they can put into their specs or validate a product for use and against a specification that they have. So that's really it for me. I'm going to hand it back over to Sadia and Vasilios to head us out.
Thank you, Scott. That was very informative. I'm just going to quickly look and see if you have any questions. So it appears we do not have any questions. So for all the attendees that are attending, if you have any questions, please feel free to reach out to HRAI. And with this, I would like to end our presentation for today. I hope our members found this informative. Additionally, please complete the evaluation survey that will appear on your screen at the end of the webinar. And with that, have a great afternoon, everyone. And thanks again, everyone at UL.
Thank you.
Thank you.
Thank you.